All right, we're going live on YouTube right now, and let's make sure everything is set up. Perfect. Okay. All right, thanks for everybody for showing up. Tonight we're going to talk about navigating the prototyping process. This is something that we all have to go through, and I feel like people trip this up all the time. So as far as background, being in manufacturing, I get to see a lot of people's impressions and approaches to prototyping and what they expect to get out of it versus what they actually should get out of it. So we'll go over a couple of topics related to that, and I'd love to have your questions or your concerns about going through. Let me just, what did I just do? Sorry, bear with me here. All right, cool. Yeah, so I want to bring up some examples of hangups that people have had walking through the prototyping process, and really the top mistakes that I see that are made in prototyping. So the hook for this is your approach to prototyping will cost you thousands of dollars, and I've definitely seen people make some of the mistakes that we'll talk about later that have cost them tens of thousands or hundreds of thousands of dollars because they've failed to actually properly test and prototype their product. So I want to cover the various stages of prototyping in the product development process, from the very early stages all the way up to, hey, we're ready to place an order for 1 million units. Everything's fine. Everything's tested. We're good to go. And I really, with each of those types of prototypes, each of those stages, I want to go over what questions each of these prototypes are meant to answer. Like why are we prototyping and what should we get out of that? So a little story time out of this. We can make up a character. Let's call him Startup Stanley, right? Has an amazing idea and thinks, okay, I'm going to print some parts and then I will be able to give that to a factory and they'll be able to make that product. And that could be the case for very simple products, but when we see complex electromechanical products, innovation products, there's a lot more steps involved. And I've seen time and time again, I've seen somebody like Startup Stanley go and they try to get funding, or they try to do a Kickstarter, they try to go to that next stage, and they realize that what they have, although fantastic, can't really get them past where they are. And if they're talking to hardware investors, the hardware investors know this, and they know that they don't have a fully commercialized idea, but they push forward. And I've seen people push forward, mortgage their house, spend their kids' college fund, spend a lot of money to then take that product, and they think, with a little design for manufacturing, we can make the tools and we can scale this up. They scale it up, and it can't be cheap enough because it's not designed for scale. It doesn't, other people can't put it together. There's a lot of yield issues with the product. So they haven't gone through that due diligence process of solving these problems iteratively or in smaller increments and get ready. So where they think that they're being really fast to get to market, because they're Startup Stanley, they're like, oh, I'm on fire. I'm going to take over the world. I'm going to move really fast and break things. That's what Mark Zuckerberg said. And they just end up breaking their own life, right? Because it feels like you're doing more work. It feels like you're getting farther down the road, but you're just taking that risk and compiling it all into one giant bucket instead of mitigating it step by step. So we're not going to be like that. What we're going to do is we're going to use prototypes as a tool, and we're going to think more like scientists. We're going to approach this and say, this is my hypothesis, this should do this, and we're going to solve each piece and cancel each assumption into a known. So we're going to transfer assumptions into validation. So this is a different way of thinking about prototyping, right? The purpose of prototyping is to answer questions and reduce risk through action. It's not to create a first unit for sale. the purpose of it is to learn. So really what we have to ask is, what are we learning from each step? So before I just barrel on and get excited about making odd widgets, whatever is in your mind, feel free to raise your hand, put a question in the chat, so I can be thinking about that, and I can circle back to a specific piece of content if you do have a question, because we're going to go over these at a high level, but prototyping is very particular, right, to each of you. You each have a personal project or a personal past experience, and I do these live so I can give this content context, right? We can't all be at the garden or all be at Mason, or we can't all be at a location and talking in the same room. So this is the best I've got. If you've got questions, please put them in the chat. So what does this process look like? I like to split up product development. And if you've listened to me rant about how you develop ideas into realities, we have two main things that are happening. We're developing the business concept and we're developing the product concept, right, at the same time. And there's varying levels of effort at different stages, but right now, tonight, we're talking about the product. We're talking about the product development, and at some points it touches that business development, that customer development process as well. But by splitting up the prototypes into these same phases, it gives us a lot more opportunity to gain insight from customers versus just making something and like letting it rip. And if you're listening to this and you have like a software only startup, congratulations. That's the development of that's a lot easier, but you'll see that these same phases could be applied as well. It's instead of industrial design renderings, we'd be talking about wireframes, right? Instead of a looks like prototype, we'd be talking about UI UX design, right? But you can split up product development into a concept phase. There's a dual design phase, and we'll talk about what those two competing pieces of that look like. We can split it up into for the purposes of this, let's split it up into concept, let's split it up into design, and let's split it up into a validation manufacturing phase, right? I'll make it simple. So for the concept phase, we just have an idea in our head, which is great, but we can train our brains to come up with 100 ideas a day. And oftentimes the ideas that are in our head are more nebulous than we really want them to be. And the first prototype of, hey, will this thing fly, is to be able to write it down. So if you're looking at engaging a product development firm or even an engineer that you meet, a helpful tool that we use in industry is a product requirement document, right? So this would have the functional requirements, like this thing should do this. It might have some market requirements, but it also, our PRD includes initial sketches, it includes system diagrams, it includes questions about market information and like other assumptions. And the great part about having this as your initial prototype is like you're building a set of requirements of what this thing actually is before you 3D print something, before you really involve in what you're about to discover and validate. You have to know where the gaps are. So if you start gathering these requirements and you say like, I don't know how to answer a bunch of these questions, that's good. Gaps are good because it shows you where you need to focus your effort and what problems that we're going to be solving later. So it's very critical. A issue that I'll see people go through next is they think that they need to design the product in full, as if it were to be then injection molded or it was then to be made. And if we want to take a more iterative approach, a more discovery-focused approach, and this is how amazing products are built versus something that we just want to get out there as quickly as possible. We want to build a proof of concept prototype. So in a proof of concept prototype, we're going to hack this thing together from existing products. We're going to try to, on a system level, hack the technology together without infringing on intellectual property. So going out there and kind of looking at that, what that tech landscape looks like. And as we start hacking this thing together, you might be using Arduino, right? Instead of a custom built PCBA. You might be taking apart toys or taking apart kitchen appliances or something in your house, right? You might buy something from Alibaba and take it apart and build your own robot versus building it from scratch. Can we rip something apart and make a Frankenstein? Can we hack this thing together to learn as quickly as possible? How do products in this space look? How do they function internally, right? This is going to leapfrog our ability to create a fantastic product because somebody's already spent hundreds of thousands or millions of dollars in figuring this out. So we want to gain that knowledge as quickly as we can. But more importantly, like I want to see, is this something I want to pursue? Is the science of this real? And a lot of ideas fail to meet this initial checkpoint, is they can't be properly defined. And if you don't know the landscape enough to start cobbling together like a partial feasibility type proof of concept, it's hard to understand what success looks like. It's hard to refactor that product's requirement document. It's hard to relay that information to someone else. So at that point, if a proof of concept prototype looks impossible, I suggest to people that they build a different team or start focusing on how the success of the business would look like so they can facilitate this process a little bit better. Maybe they need a different partner. Maybe they need a different, outside partner or a inside business partner and another founding team. I think that's important as well. Fred asks, what are ways to mitigate risk when the project timeline is compressed to the point that limited or no testing time is available? That seems to be always the case, right? I think so. I have this joke, and I always every project, I think after you develop enough products, it's never like an engineering challenge anymore. It's never like can this be done? It's always an expectation management problem, right? So if you're dealing with investors or other team members, building a development roadmap, a tech roadmap, is really, really critical. So my first piece of recommendation, and I know this isn't 100% helpful to your situation, Fred, probably because you're a little farther down the road, but my critical piece for coaching clients, for anybody that's going down this, that is thinking about bringing on external parties, is to create that tech roadmap. So you can say, like, this is how long it should take. And roughly, I always estimate people's products as simple, medium, and complex is 6 months, 12 months, 18 months. And every time I tell somebody that their product's going to take 12 months, they say, no way, there's no way that it's going to take that long. And then I see them 3 years later and they haven't developed their product because they don't want to put the process into a map. And we want to skip all these stages and compress things. And by compressing things, we skip things, which means we don't really move forward. So it's like in government contracting, we say it's hurry up and wait. So it's a lot of hurry up and waiting stuff going on. But yeah, there's ways to mitigate risk when project timelines are compressed, limited no testing. I mean, the biggest risk is your customer dropping out. So managing expectations is important. I think that leveraging existing existing things as much as possible, if not components off the shelf, like subsystems off the shelf, or building something and saying this is what the V1 of this will do, and then V2 will do this. So as we look at these prototypes, and we're saying we're making a promise either to ourselves or our partners of what that prototype is going to do. Like, what is it going to actually solve? So if I'm building something really complex, oftentimes one of my prototype stages is just to get it into testing, and it's trash, right? It literally is going to be electrocuted and set on fire. So I'm not going to be able to sell it. The whole objective of it is to learn, will it pass that, or is there something that needs to change? So um, we can look at which of these processes for low volume. I think when we get to the manufacturing validation stage, the third stage, we can talk about which of those stages that we can skip, because if you're working in low volume, we have a little bit more control. We can talk about that more, because one of the best prototypes is, can somebody else do this? Jade asks, what stages should you check in with a certifying authority when you're developing a highly regulated product? That is an awesome question, and we're going to go over let's say 3 stages, which I think are really good. Depends on how much information you want to initially externalize. That might be for investment or intellectual property purposes. But when we go over the DVT units in manufacturing validation, those are the ones that are generally going out for complete certification, complete compliance testing. So we'll get to that. But that is the big question. I just had another product pass UL, and that's kind of the stage of that. You can't just slap something together and then get it UL approved. So we talked about the concept phase and what we're trying to do. And I like to break things down very granularly. So if you're saying, Callie, that's not an actual prototype, you're saying draw something on a paper, write the requirements down in an organized way, and then cobble it together. So like, how's that a prototype? Because the purpose of a prototype is to learn, and we're trying to learn as quickly as possible. So if I can break that down into small, low cost checkpoints, right? We're mitigating that risk that entrepreneurs have, saying like, I don't have the time, I don't have the money, I can't move forward. I have this awesome idea in my head, and it's just total lies. The next stage, we're moving from that concept over into design, and you'll commonly see this bifurcated to industrial design and engineering. So a lot of the people that I work with, they live in that engineering world. But as soon as it touches reality, what sells products is oftentimes not just, its features. It's the way that people feel about something. So as frustrating as it is, we want to look at that user experience of a product, what it looks like and what it feels like, and we want to explore that. And I find that it's helpful to explore that initially, because an industrial designer might not focus as heavily on something that is manufacturable, and we can get a look and feel of a product. But then when we start getting into the engineering realm, we can tweak that look and feel based on what a reality is. But we have a good direction to go. I used to want to draw comic books. I like drawing. I like sketching. So I find that the process that works for me is that sketches and renders allow me to accomplish a whole lot without having to spend 10 hours 3D printing and sanding something. So if you're looking at the form that a product might take, even if you're bad at sketching, a bad sketch is better for crystallizing an idea with your mind than no sketch. And if you're trying to communicate ideas visually, I do recommend spending some time sketching something out on paper before you jump into CAD. But having a CAD render of just like the block of what your product might look like is nice. It's very illustrative. You can make a form study of multiple different shapes of what it might look like and talk about it and talk it through with everyone else on your team, and you can accomplish a lot very quickly. But what we're really trying to do in this design is we'll eventually end up with a looks like prototype, and that's going to demonstrate the look and the feel of the product. We'll be able to select the color, material, and finish, or CMF, of the product, and we'll be able to put that into our PRD. And I primarily want to focus on ergonomics, the form, the size, the weight, so like the user experience of a product. So yeah, we want everything to look cool, but what is the expectation? And that can drive some of the engineering requirements as well. So if you know that some dude has to have this thing on their back all day long out in the field, you want it to be as light as possible, but you want it to be as rugged as possible. So like what's comfortable on somebody's back and looks good, right? And exploring that is going to yield different shapes internally, which is going to then inform the shape that the PCBAs might need to be, right? And there's a little back and forth here. But I oftentimes live in this prototyping and design world of the engineering portion of it, the technical portion of it. So our goal on this side is to end up with a looks like prototype. So I'm sorry, a works like prototype. And it could be built on a bench. It isn't a 3D printed shell. It's not, oftentimes it's just built literally on a bench or on a board. And instead of using an Arduino, it might start using something that's closer to the actual boards, right? It might actually use the real connectors that you want to use. And it might start using the real mechanicals, like if it's an actual motion product. But oftentimes the works like prototype is kind of nasty. It's a little bit bigger than it needs to be. And we're just trying to figure out on an engineering side what it should be, what it actually should be with the technology that we can afford and we have access to, with the knowledge that we have access to, with the resources that we have access to. Can this thing be built on a bench? And then does it actually do the thing? Does it actually accomplish the task that we thought it would? And it's a really simple question, but oftentimes translating our idea into thing that actually performs the task that it's supposed to on a fairly reliable basis is a huge impediment for people. And this is more of a reason why to focus on that versus what our next prototype is, which is an integrated prototype. And this is kind of what I was saying is like most commonly people think of a prototype as an integrated prototype or a looks like, works like, LLWL prototype. And if we break up these steps individually and we think about things first, we can solve ourselves a lot of, instead of iteration, just kind of like infinite looping where nothing's quite right. So our integrated prototype is, Jade, to your point, if I was checking with a certifying authority, that's probably the first thing where I would be looking at externalizing some of the information if possible. It's probably not show ready at that point. And if you're looking at UL or other types of testing, you can't use 3D printed, plastic. You have to use the actual materials that will go to market. So there might be some difficulties there, might be some workarounds there, but certainly if I'm working with investors or I have a boss, I would be showing off that works like prototype. I'd be showing off that looks like prototype, right? I've even seen at shows where people have the looks like prototype sitting on the top and they have the works like prototype underneath the table. And the looks like prototype, some home IoT device. It's got a nice little LED in it. Looks like it's working. But really, there's a big old computer and wires all over the place underneath that table, and it's doing something neat. But integrated prototype, what we're actually trying to solve is, can it all go together, right? And the answer is almost always no, it can't. And we have to make changes to the design. So we start tweaking that industrial design, we start tweaking our mechanical design and normalizing everything, getting all of it to fit into the package, getting it as small as we can. This pushes a lot of knowledge about what needs to change from a manufacturing perspective, because maybe you've printed all the parts from, up until now, and yeah, it's going to be injection molded. So this is the first time that once you know the shape, you can start making design for manufacturing decisions. Don't make them before, because you don't even know what you're making. People get caught in the weeds optimizing, a point that you don't even need to address right now. So right now is our first chance to start looking at it and saying, how can we make this thing stronger? How can we get it to use less plastic? How can we, how can we tweak this back and forth? But we have a couple goals for the integrated prototype beyond just, can it all fit in the box? Can it all go together, right? We want to know, can we effectively demonstrate this to others to get feedback, interest, or investment? And startups will often conflate an integrated prototype with an MVP, because they feel like, hey, this is like the first iteration of my product, I can show it to people. It's a totally different concept. MVP being a limited, quick release version of your product. This is a prototype, so it's just an early version of something that is, it should be actually the thing. It should be actually your product. It's just not made for mass production right now, right? It should look reasonably similar to what it would look like in the final, and it should actually function. But I want to go out and I want to get feedback, interests. This is where people use this product to then go get investment from, because it shows that you can follow your tech roadmap. It's pretty easy to cost out the rest of development from this point, because I know that the rest of the prototypes, I could look at something and tell you how much it's going to cost. Within a day, I could give you an accurate, cost of what those steps will be, what the tooling would be, like how long it's going to take. So from a standpoint of wanting to get involved in something, this is a good place to start looking at that. But maybe more importantly is, when we build this, and we'll build this ourselves, we'll know what the QC process will look like. We'll know what the assembly process would look like, and this gives us some early inputs to start building that documentation. It's really important, because the next prototypes we're not going to build, somebody else is going to build them, and this kind of throws a wrench into people's work. So I want to go over EVT, DVT, and PVT. And this is like more acronym word salad, but trust me, for large volume commercial products, it really is helpful to break these up into different categories versus just going from, we have an integrated prototype and a CAD package, let's make 1 million, or let's make 1,000, or let's fulfill all of our Kickstarter orders, or let's send this to our investors. So let's talk about this. So EVT is engineering validation test, and what we're really, the primary goal of this is very simple. Can someone else build this? So it's generally made with lower volume manufacturing processes. So instead of injection molded, they might be urethane cast, or they might use soft tooling versus hard tooling for injection mold, right? They won't be made on the exact PCBA line as your production. They'd be made on a smaller machine, right? They'll take your assembly documentation, create their own assembly documentation, but a contract manufacturer or a CM will actually build these units. And that's, to me, one of the most important parts, is we're going through this check gate of, can someone else build this? And I recommend volumes, and it depends on your final volume is, but between 10 and 50 units. We want something that's statistically significant. Anybody can make one thing work, but to make 10 of something and them all be the same it shows that the process is stable, that they understand the requirements. This is also a way of validating the factory that you would be working with, or validating the CM. But a piece of pushback is that they will make mistakes. Even a good contract manufacturer will make mistakes in assembling the product or understanding the requirements. And if they ask questions, that's great, but know that the point of the EVT is to suss out these problems. It's not to avoid them or to have no problems happen. It is to have the problems. If you get no feedback and you have no issues, I would be afraid that something is being hidden, or we're not quite where we need to be. So, Fred, to your earlier point, for lower volume products, you see, like, if I'm only ever going to make 10 of something or 100 of something, there's no real point in going through EVT, DVT, and PVT. So you just break up these requirements and you kind of do these yourself, right? Or you hire a team that will help you assemble, and you're doing this internally. So you'd see this compacted quite a bit. You might even have your integrated prototype, what you do to pass simple tests, versus breaking this up. And I'm going to mention quantities that might just not make any sense for lower volume products. So we can get pretty deep into what this process actually looks like, but just understand is, like, if you're getting somebody else to do something, even if you've made it yourself, don't have them make your full volume right away. Have them do a small pilot, right? Or have them do this EVT process to make sure that they can actually follow your instructions. This will save you a ton of money, and is, again, one of the most common mistakes that people make. So moving on to DVT, the design validation test, we're going to move the product over onto the real machines. And this is where we're getting, hopefully, our last pieces of design for manufacturing feedback from our contract manufacturers. This is where we're going to understand what our yield is. So a great story. There's this really cool Kickstarter where they had this super thin wristwatch, and smartwatch, and it looked like a little bangle. So cool, right? And they raised a ton of money. But every CM that they went to, including the biggest CMs in the world, when they got to this stage, the yield was so high. And fun fact, if your yield is super high, like your yield, I'm sorry. So, like, let me explain this. Is like, if I'm making 100 of something, and every time I make 100, 5 of them are no good, and I have to throw them away, a contract manufacturer will charge you either directly or indirectly for the manufacturability of a product. So this bangle was so hard to make that that the contract manufacturer ended up charging them for just hundreds and hundreds of thousands of dollars for the low yield of their product. And if they had gone through this process and said, like, hey, our yield is super low, we only get a couple per 100 of this product, and we have to sell hundreds of thousands of them, this needs to be redesigned. But instead, they pushed it forward, and they got massive bills just trying to get units through. So we want to understand our yield on the actual machine, using the actual assembly people, using the final assembly documentation. What other problems are we going to encounter? So these are the units that we would use to pass compliance testing. So I would get them, and I understand that DVT, there's still things that we want to fix and prove, but these are the ones that I would send to UL testing or industry testing. These are the ones that we'd send to, like, Mill Standard 810 testing or 901D, where we blow up a barge next to a product, which is always really fun. But yeah, the DVT units, they should be at a level of maturity where they'll actually work. legit work and they're using the real material and they're using the real processes. So inevitably there's something that needs to change, and that process can be slightly iterative. Like you might have a FCC compliance issue, you might have like a battery issue with its longevity, you might have something that happens. But all in all, what we're really trying to do is we're trying to push things to compliance, get them to pass compliance, and then we can move on to PVT, which again, it depends on the volume of your product, but for commercial products that I would do, that this would look like 500 to a couple thousand parts. And these units, if everything is good, these are sellable units. But since they're the first units that are made, in its final form, no designs made, they're in the opinion of the industry, they are prototypes, right? That these will go in their final packaging, they'll use their final logistics route. They should be sellable. These are show-ready units. So what we're trying to find out is our supply chain secure? Do I know how long it takes from initiating an order to receiving it or a customer receiving it? Am I going to get shipping damages, right? I'll also know all of my information on pricing at scale. I'll have refined documentation. I get all of those things and I'm just checking. And what is funny about this is that this is the first time where my opinion of what a prototype is and what other people's opinion of a prototype is lines up. So people think like, oh, prototype is this thing, or I'm going to make one and it might need some tweaks, but it's going to be sellable. Like, that's all the way down in PVT. So most likely these are sellable units. But for when we layer this on our business development process, these are usually the units that I'm sending to our early adopters, to our fans, to influencers. I'm saying like, hey, you're a part of our development and maybe you saw our DVT or maybe even got a hold of the DVT and some pilot testing with us. That's fantastic. Here's your unit. And this is what I'm using to build steam and build in collaboration so we can, instance our go-to-market strategy. But I still consider them prototypes because we're trying to learn information. And again, when we layer this onto our go-to-market strategy, our actual business, there's a lot of business-related things that we're doing with them that's kind of outside of tonight's conversation. But each of these phases, you should be able to imagine how they engage in building the startup and in pitching the startup and building the team and building the marketing presence, because we can all use them in some way. If nothing else, for an awesome story, right? I advise you to keep all your prototypes, right, and document them, because as you're successful, it's just so cool to see like the stages of stuff. So I really like that. So let's move on to the top mistakes made in prototyping, unless you have questions, and feel free to chime in. Jade, you've only asked one question tonight, so I feel like this wasn't the topic for you, and maybe you could ask a bunch more questions. But no, I appreciate you. Top mistakes that are made in prototyping. These are so the top mistake, and I probably already said it 2 or 3 times, so it bears, and that's worth repeating, right? Planning for a single round of prototypes. That's the number one mistake that people make is, and I did this in our customer discovery talk, is people have this idea, and if you've seen the South Park episode, you'll know what I'm talking about, but it's basically like question mark. They're like ideas, prototype, question, money. And I'm like, oh man, no. They plan for you just to 3D print something one time and then boom, go to production. And I'm like, I really wish things worked like that. We would be living in some hard sci-fi super future right now, but that's just not reality. Reality is that we're flawed and our ideas are flawed, and like we have to overcome those challenges. And its difficulty is part of why we find it so rewarding. So we have to kind of like understand that about our brain, is that because it's hard, that's why we want to do it, not that we should avoid it because it's difficult. So that's the number one mistake that people make. Number two, and this is a good one as well, is making multiples of the same prototype. Like, we like iteration, but I don't like multiplication. Okay, so like if we're making our looks like prototype, why 3D print 10 versions of the same thing? Like, if we're making our integrated prototype, why make 10 of them? You know, and people will invariably say something like amazing, like, I have a trade show to go to, or I need to show this to an investor, or I need to do this thing, this fiction. And I tell them, like, if you make 10 prototypes at this stage, you've made, for however many mistakes that there are, and there will be mistakes, because that, again, that's the point of prototypes, is to discover these issues. You've made them times 10. So they're sanding 10, parts. They're readjusting the wiring, and they're taking apart and desoldering 10 PCBAs, or they're reordering these parts again and again and again. Like, just make one thing. Our goal isn't to make a product. Our goal is to learn about what we need to do from the prototype at this stage. And we don't learn anything more by doing 10 times the same mistake. We just spend more money, and it takes more time. It's not faster, right? So we want to speed things up. We don't want to, I don't know. For some reason, everybody does it regardless. I say don't do it, and then people are like, well, it costs the same per unit. Like, it's just 3 times as expensive to get 10 parts as it is to get one. I'm like, it's not, because you're going to have to spend your own time fixing all 10, or you're just going to throw them away. So, and be good stewards of our investment money or our own personal capital. So don't do that. Feeding off that last point, and maybe addressing what Fred was asking, is oftentimes in projects, there's other parts of our team, maybe they're those pesky marketing people, right, that are floating off in reality, and they've made some arbitrary or external deadlines. Like, we need to go to CES. I've heard that a million times. Oh, we have to go to CES and show off our product, and we want to cut through all of this stuff so we can just get out there and we can get some sales. I'm like, what's going to be better, going to CES with a terrible product that ruins your brand, or waiting another 2 months and releasing online a great product? And smart people wait, right? They wait, or they refactor what they're going to offer. And that's part of why we have our traction strategy, where we take that product idea and we turn it into a hero product and build a roadmap towards it, where we're releasing other products or versions of that product to inevitably get there. But we don't try to build something and squeeze it in and say, hey, there's a guy who's in town, like, can you put something together overnight so we can give him this demo? Can we go to this random trade show? I think, this guy's going to be there, and this company's going to be there. I want to wow them. And like, you're never going to wow them, because you're just going to make garbage. And that's going to hurt your brand, which long-term hurts you worse than just not showing up. Trust me. All right. Now we got some good questions. Jade has a question about spec sheets. What is too much and not enough, and how to address the defect rates in QA when you get into manufacturing on a small batch? How do you handle versioning with different modifications? It gets messy real fast. Fred, we do need to go to CES. You should go. It's not quite as awesome as it used to be, apparently. But you should go to just to spy out the market and see all the cool tech. Don't arbitrarily buy a booth and show a halfway finished product. IMTS is better. IMTS is canceled, but it is better right here. Here's my mug. Yes. Okay, so there's a couple questions here. Let's talk about version handling, because that's something that we do pretty well at K-Form, and it's something that with Red Blue Collective we're working on right now. So there's different technologies that help you do this, and it depends on how far in the weeds in manufacturing you get. But generally, there's products called PDM, or product data management, that they handle the process of managing those files, allowing you to check in, check out, allowing you to roll revisions or send them through business processes of like who has to approve what. So changing everything on the CAD is then controlled. It's very difficult to control what people do on the fly, but it's helpful to have a single point of truth, and PDM helps you do that. There's a couple of different products that do that. If you're farther away from the actual manufacturing, PLM, or product lifecycle management, is the discipline that kind of manages like where a product is in a general sense, like across from opportunity to the product's eventual death. But me being more in the technical weeds, like I look more at like we're looking at new ERP software, enterprise resource planning software, and integrating that with our PDM tools. So all the CAD and bill of materials management is integrated across manufacturing, whether it's here in Sterling or in Shenzhen or wherever. So we can talk about that in person, but it's basically using massive enterprise software to do stuff. There's a cool update for Fusion that's happening where it'll be a little bit more helpful, but Fusion is really, really, really bad at PDM to the point where it's, in my opinion, unusable for a professional, but it's getting there. No, it doesn't. It does not. It does not do PDM. Let's see. What is your specific question about spec sheets? You mean like drawings for mechanical parts, or what do you mean? And if Dan knows how to do it, he should tell Autodesk, because Connor and I just had a demo with them, and didn't go so well. Their Vault product works really well with Inventor, but it doesn't work with Fusion very well. And but if he knows how to do it, I might have a job for him. Oh yes. Okay. So drawings could be a whole nother topic, and so we're hiring external contractors, and I'm trying to train them how to make drawings. I've been looking at drawings since I was like 10 years old, and it's not immediately intuitive of how much information. It depends on the type of manufacturer that you're going to. What is getting more and more popular in the United States for technologically advanced manufacturers are minimally dimensioned drawings. So the drawings really need to convey information that's not available in the model itself. So like tolerances that are over a global standard, particularly material, finish, better weld notes, those are helpful, but whole callouts where they have tolerances that are tighter than, say, the general profile tolerance. So a common example of that would be sheet metal that has a PEM hardware inserted into it versus just a through hole. So you need to have adequate information that relays the design intent. So if I put a pair of calipers on it, that you would get the part that worked the way that you actually want. And for more critical parts, that might have more critical quality control information. But essentially, drawings used to be a manufacturing a manufacturing document, and more they are quality control documents, or they're more of an agreement of this is what the product will do. So yes, we can go over some specific examples, but you know, like each component in your product has to have an individual drawing. It has to then have tolerancing that allows it to integrate into the full product. And this is one of those things that's really helpful in our prototyping process, because if we get other people to make something, in general, if our tolerances aren't right, the part won't go together. So part of the art of design is making designs where it's a little bit more forgiving. So we can have plus or minus 5 thou or 10 thou on drive costs. So if we're and on assemblies as well. Yep. So if you'd like, we can have a whole live stream, or I can do a podcast that's on drawings, and I can show you some examples, because I make products that have hundreds of parts that go together, and the drawing packages could be 200 plus pages, maybe 300 pages long. You literally need to be able to send each part to a different factory and then be able to get it all together and it go together. It requires a lot of thought. But again, that's why we get somebody else to make something. And that's why I try to get people to have somebody else make parts as soon as possible, because then we can see where we need to adjust those tolerances, even maybe before the EBT stage. So I can know what I'm gonna get. Like, oh yeah. Jade says, remember K-Form Monday? That was our Design for Manufacturing Mondays at K-Form, where you showed the standard milling end mill widths or diameters. I think we showed the different types of end mills. So there's lots of design for manufacturing flaws that people get into, like milling sharp corners, bending things where the hole to hole across 2 or 4 bends is super tight. Yeah, but we can do a whole session on design for manufacturing, or we can do one on drawings. I think that would be great. Be kind of in the weeds. I mean, I like that. People definitely get tripped up on it, and they waste a ton of money because they design things that can't be made, so they have to refactor a whole nother set of prototypes. Where DFM, a lot of what I do at K-Form involves DFM for other people's products. So running through an entire product and decosting it, right, and making it so it's easier to make, or more repeatable to make, like higher yield at lower cost. For fun projects, usually not defense contracts, we figure out how to make it also look cool at a low cost. But in general, for highly technical products, people don't so much care what it looks like. They just want it to be really rugged or really do the thing for a long period of time. So Jade says, if you don't design with a standard or understanding how it's made, you lose how to optimize it. Absolutely. So we've done a couple of innovation classes for large companies, and one of the biggest takeaways for them is they just saw how the process worked. And by seeing how the process worked, they became better engineers and better designers and better problem solvers, because we know the truism from design is that constraints make good design. So meaning that we can make better design decisions when we have to really think creatively, right? Maybe when we have less money or we have less tools, we have to actually think about the solution instead of just hammering it right through. But for coming up with manufacturable solutions, it's helpful. The best engineers that I have ever met, they had spent a summer or a couple of years in a machine shop or a fabrication shop, or they have one in their basement, and they know how all the tools really work. So when they build a prototype, they know, hey, this is where all my tolerance in this assembly is going to stack up, and I need a place where I need a slot here, right? Because it's going to be so constrained. If I make these precision holes, it's going to be over constrained. But again, if we're looking at the prototyping process, Jade, as we engage our manufacturers and our contract manufacturers, and we've talked about this in partnerships, we really should be looking at that relationship like a partnership. So, you know, if you're not using Kform, you're using another company that will give you some design for manufacturing feedback that's on your product. Certainly, when you go to assemble it, you're going to get some feedback whether you like it or not, right? But this is why I like other people to make the parts. This is why initially I like to try to put the thing together myself. Um, you know, on a really simple basis, I have gotten the same 3D printed part made by Fictive, and I've got it made by Xometry. And I know that Xometry does -5 and Fictive does +5, and that's a big difference in between the two parts, and they won't go together, right? But if I tolerance the drawing correctly, like, you know, maybe I could get something more repeatable. But it's just important to have that hands-on information, especially initially of putting something together. What point should you scrap your prototype and start again from zero? Too many products stuck because it loses doing something well to span more uses. Yeah, so for prototyping, we really want to look at it without ego and look at it that we're trying to learn a specific, we're trying to gain a specific piece of knowledge. We're trying to learn from it. The temptation, I like using that term temptation, because when we start talking about what we think and our ego, that's really what it is. It's like we know we shouldn't do something, but we're tempted. We're tempted to do it. Hubris, that's right. The hubris to take on the gods, right? No, but like we look at it and we say, well, I'm pot committed, right? So I have this loss fallacy that I put all this time into this thing being shaped like this or using this component, when in reality, if you design with linear iteration, you always will end up with an inferior product. You will always end up with something where you had to make a ton of compromises and slap stuff together. And you'll be able to tell because the product will look wonky, right? When in reality, what we need to do is we need to learn something. We need to set the learning in stone, and then we need to find what other assumptions that we're making, what other questions that we have, and we need to go about solving those. And we need to integrate our answers together in a prototype, right? And the integrated prototype allows us to do those. So if we follow this process, we can do this a little bit more effectively. But I mean, I'm working on a project right now where the requirements keep changing, but other requirements aren't shifting. So you end up with something that's like more cobbled together than you'd like. And the person that's doing it said, well, what do you think about this? And I said, I don't like it. I don't, because I think that it's cobbled together because you've linearly added requirements versus saying, okay, now the requirements have changed. So 90% of what we did looks good, but like the box has to be different, obviously, you know? So that's a really good question. What I would fight if this is gone farther is it's very hard to get past like an integrated, early level integrated prototype like that. And if you've learned enough, it might be helpful to just go back to the beginning of the process like this, right? Is go back to the beginning and sketch up what the ideal version of that product would be, because you've learned so much. Just think like, hey, maybe I can spend one day sketching it or one day rendering it in CAD, where I take all of my lessons learned and put it together, and then you can talk about it and say, hey, is this worth pursuing? And if I pursue this, will I have the same roadblock again? And what we don't want to do is we don't want to like just keep resetting over and over and over again, because on the business side of things, if we're not launching and showing it to customers and gaining information on that side of it, the longer we spend in development, the more time we're wasting, the more money we're wasting. You know, it's nothing's actually happening. We're not actually developing a business. We're just doing like a hobby project. So the trouble with starting over is that you could continuously start over forever, and you never actually get to the finish line or any finish line. You just are stuck in perpetual maker hell. So that's my piece of that. And that's definitely a common thing as a coach and consultant that we deal with is, okay, that would be a nice thing for V2. Let's put that over in the V2 pile, because we're not going to do that this time around. Awesome. So we're right at 1 hour, and yeah, this has been fun. But I was afraid with more of like a technical stream that people would be less interested. But you never know. You never know. So I'm excited for switching over to StreamYard and pushing things to YouTube and Facebook. So we'll really be promoting next week. I have no idea what we're going to talk about. So Jade, if you have an idea, Amanda, you have an idea for what would be like our V2 premiere of End Hype Live, then I'll do, you know, I'll do that. Jade says, it is so important to learn more about what you don't know. That's right. Yep. Again, our temptation is to want to start over so we can prove to people how much stuff we've learned and how smart we are and how much more mature and how farther along we are, to exhibit mastery, when in reality, the whole purpose of prototyping is to discover what we don't know, right? And great products are relentless in discovering things that we don't know. And great entrepreneurs are relentless in, you know, teaming with people that know how to do things that they don't, and you know, figuring like uncovering things that they don't know how to do. And people that are stuck, you know, they never have to prove anything to anybody, because Netflix and a couch are always there, right? So it's like we can be perfectly discontent, or we can be passionately you know, content but kind of dissatisfied, and just like, you know, constantly learning and finding problems and growing. And that's how we become awesome. Or we can just sit here and be proud of all the things that we know how to do. Look at all the books I've read. So smart. Let's talk about what holds entrepreneurs back and how to support each other. That's awesome. Yes. So my course opens up with break assumptions. And I'm starting to catalog even more things as I've really ramped up the coaching of ideas that hold people back. And the simplest way that I phrase this is stories that no longer serve us, right? I think that's the easiest way to think about it, but and maybe the kindest way to think of it. But we tell ourselves stories that get us through school, or get us through that job, or get us through our first startup, or get us through a relationship, and then we bring that to innovation and they don't serve us any longer. So a lot of that is that, but it pops up in a lot of different ways. So I think that is an amazing topic. If people can stand more of a mindset strategy live stream, and you can hear me be be Monk Callie, not Dr. Callie or whatever. So Jade says, other people's limited vision telling you what you can't do. Oh man, that's for real. That's for real. I love that, because no matter what you do, I just had somebody yesterday who doesn't know how to do the thing that I'm already doing tell me I don't know how to do it, or that I can't do it. And I'm like, but I'm already doing it. And the part of, I guess the part of moving forward is that just can't stop me, right? And I'm just like, you know what? That's okay. That's okay. But what they're really, yeah, people, they want to externalize what they feel on other people. So I can't help them at that point, and that's the frustrating part about it. But it was like a crazy conversation either way. So I'm just like, oh, all right, sounds good to me. But yeah, people, uh, they have they have a scope of their own vision based on what they understand and what they're comfortable with, and then they'll say, that's why Jade can't do it. I'm like, that's right, less competition for being awesome. I'm like, I really would have liked to collaborate with that person, but I guess I'm just going to move on because it's not a good fit, right? There's one of those dumb little, Instagram kind of sayings where it's like, whether you believe it's possible or not, it's true. And I was thinking about that in the car, and it's just like one of those dumb little sayings, and you think about it, and you're like, yeah, but there's a lot of truth to that, right? If you think something's impossible, it's impossible. But I don't know. Yeah, I think that's a great topic. Let's do that. So next week, um, for people that watch, I'll be posting next week's live all over the internet. Please, uh, sign up, but please share, because I'd like to get the word out. We've done this a few times, and I'm going to be promoting it pretty heavily. And there's still a lot of pushback because people see live webinar and they think like, hey, this person's going to try to sell me something. I'm like, I don't really have much to sell. I mean, you know what I do, and I'm pretty available. So, but I also pretty much just give away whatever I know. So we should talk about that. Resources are great too. Resources are great. How to get resources, why sharing and connecting resources is an amazing business strategy. That would be good. But I'm going to promote it pretty heavily. Please help me and get the word out. So when I put out the email, when I put out the post, if you get value out of this, please share or invite a friend. I really appreciate it. That's the only way that we'll get more people and we can help more people. So, and if you have a topic coming up that you'd like to talk about, I might rope you in, Jade. I might rope you in, Fred, and we can do a live. We can do a live together. In a couple weeks, we have Kelly coming from HS Draconis, and that's going to be cool. We have a couple other, great guests scheduled. So I really enjoy doing that. NASA, yes. If anyone can teach somebody from NASA how to properly do a go, no go and commercialize an idea and communicate an idea, if somebody can figure out how to do that for NASA, I got to get that person. And that person's Kelly. And she's going to talk about that, of how you assess an idea and make that go, no go decision, and how you commercialize big ideas and how you communicate them, even if you're so smart, you barely know how to talk. So she's awesome. And she'll be on in 2 weeks. But next week is our big live stream. I didn't want to do that with a guest because I'll probably screw up the tech stack, and that'll just be on me. But hey, I appreciate all of you. I'm going to go home and get back to work. So if you have any questions, feel free to message me, DM me, and we'll schedule a call and talk through whatever. If you have specific questions about tonight's topic or prototyping or what that process looks like specifically for you, of course, reach out to me. But I appreciate you all